The succession of Point Pleasant forests following Hurricane Juan in 2003.
Point Pleasant Park, a cherished green space in Halifax, Nova Scotia, suffered significant damage during Hurricane Juan in 2003, leading to an 8-month closure and sparking scientific interest in studying urban ecological recovery processes. This sparked Dalhousie University's Bio 2060 students to investigate the storm's ecological impacts and specifically its recovery via secondary succession by establishing study sites in heavily affected areas of the park. They collected the diameter at breast height measurements, or DBH, a widely used forestry metric that provides insights into the forest health of 2.5 centimeters or greater within the evergreen forest tree population in Point Pleasant Park. Looking at past studies, a paper from Eunice et al. From 2020 examined the post-seismic landslide evolution following the 2008 Wenchuan earthquake, emphasizing environmental succession's role in assessing when ecosystems return to predetermined states, allowing communities to determine when important ecological service might return. Similarly, an investigation from Lane et al. In 2021 measured the growth of different peatland species post-environmental disturbance to understand ecosystem resilience to environmental change. These studies signify the importance of this study, as it will allow us to identify when ecosystem services might return to the park and help organizations create protections for more climate-resilient species within the park, increasing the park's overall intolerance to future climatic disturbances. Furthermore, based on a paper from McDonald published in 2016, Point Pleasant Parks, or Amnukadi to the Mi'kmaq people, holds cultural significance to the Mi'kmaq people as an annual gathering place. This underlines the importance of its conservation, reinforcing the need to integrate Indigenous perspectives into environmental management practices.
This study aims to identify the stage of succession in Point Pleasant Park, Halifax, Canada, following Hurricane Juan in 2003. This can be achieved by analyzing the diversity of species, the changes in dominant species, and species evenness. Shannon's Diversity Index aims to assess the change in diversity in Point Pleasant Park from 2004 to the present. The null hypothesis is that there has been no significant change in the diversity of tree species in Point Pleasant Park in the year following Hurricane Juan in 2003 to the present. The prediction for the Shannon Diversity Index is that there will be a significant change in the diversity of tree species in Point Pleasant Park in the year following Hurricane Juan in 2003 to the present. Assessing the dominant tree species, red maple and red spruce, aims to assess how the abundance of Point Pleasant Park's dominant species has changed from 2004 to the present day, and how they might change in the future. The null hypotheses are that there is no significant change in red spruce density immediately after Hurricane Juan in 2004 to the present, and that there is no significant change in red maple density immediately after Hurricane Juan to the present. We predict that there will be a significant change in red spruce density immediately after Hurricane Juan in 2004 to present, and that there will be a significant change in red maple density immediately after Hurricane Juan in 2004 to present. Keeler's Evenness Index aims to identify the evenness in Point Pleasant Park from 2004 till the present. The null hypothesis for the evenness is that there has been no significant change between evenness in 2004 and 2023. The prediction is that there has been a significant change between evenness in 2004 and the present. To measure the succession of the forests in Point Pleasant Park, Halifax, Canada after Hurricane Juan in 2003, density per tree species per 400 meters squared and the size in centimeters of each tree were measured. The data was collected from the same 6 plots of forest every year since 2004 that were the most affected, as shown here. Data was not collected in 2005, 2007, and 2016 due to Hurricane Ophelia, Noel, and Matthew, as well as in 2020 due to the COVID-19 pandemic. The sizes of trees were measured using diameter at breast height, in which the diameter of the trunk is measured with a specially calibrated diameter tape 1.3 meters up from the ground. The data was used to compile statistics for total density, diameter at breast height, the Shannon diversity, evenness, and dominant species graphs for red spruce and red maple. Linear regressions were used to provide a series of regression diagnostics to quantify relationships, such as the relationship between the years past after Hurricane Juan and variables like species richness and diversity. The data for different statistics can be compared to each other using an R-squared value to see if there are relationships between variables. The accompanying p-value can be used to determine if the hypotheses can be proved or not. Species diversity was measured to compare the abundance and variety of species throughout Point Pleasant Park in Halifax, Canada, following Hurricane Juan, to analyze the changes to the forest as shown in Figure 1. We used a regression analysis to analyze the relationship between species diversity and the years from 2004, with D representing diversity and T representing time in years. The Shannon Wiener Index was used to measure diversity, which accounts for the number of species and their abundance relative to the total population. The results show that over time, the diversity of tree species in Point Pleasant Park has been increasing at a rate of 6% per year, from the year after Hurricane Juan in 2003 to the present. We reject the null hypothesis that there has been no change in diversity since Hurricane Juan due to the small p-value. Initially after the hurricane, as seen in Figure 1, the strand diversity index was very low, but increased to a very high diversity rate by 2023. Large disturbances, such as hurricanes, tend to speed up typical succession rate and diversity of tree stands, as seen in ZA Al in 2008. In the 1990s, Point Pleasant was near its climax community with red spruce and white pine as dominant species, as shown in Turchin in 2016. And as the community reaches its climax community, the forest will be mainly composed of older growth species of a diverse Acadian forest, similar to as it was pre-Hurricane Juan.
For results 2 here, we're looking at how the density of the dominant species in 2004 as well as the dominant species in 2023 have changed over time, and how it will continue to change as we move into the future towards the ecosystem's climax community. For Figure 2, regression analysis was used to explore the relationship between red spruce density and time passed after Hurricane Juan in Point Pleasant Park. There was a significant positive relationship between red spruce density and time post-Hurricane Juan based on the p-value being less than 0.002. And since that p-value is less than 0.05, we can reject our null hypothesis that there's no significant change in red spruce density immediately after Hurricane Juan to present. And then when we move to Figure 3, a regression analysis was used to explore the relationship between red maple density and time passed after Hurricane Juan in Point Pleasant Park. There was a significant positive relationship once again between red maple density and time post-Hurricane Juan, and this time we have a p-value of 0.0001. Again, since it was less than 0.005, we can reject our null hypothesis that there is no significant change in red maple density immediately after Hurricane Juan to present. The density of these dominant species, red spruce and red maple, were decimated following the hurricane. As you can see in Figure 2, immediately after the hurricane in 2004, red spruce density was between 2 to 7 trees per 400 meter squares between all 4 plots respectively, while in Figure 3 there were no red maple across all 4 plots. However, in the years following the hurricane, secondary succession processes began to take place, and in the case of Point Pleasant Park, the red spruce and red maple slowly began to regrow, as seen in Figures 1 and 2. Moving to 2023, whilst red spruce and red maple have clearly increased in density, seen in the graphs below, they have likely not returned to the levels pre-hurricane. Red maple reaches maturity after around 70 to 80 years based on a paper from Walters and Yanni, while red spruce takes 200 years until it reaches maturity based on a paper from the Nova Scotia government published in 2017. Due to these slow growth periods, faster growing fauna will likely share dominance within Point Pleasant Park until these slow growth trees have time to catch up to them, based on a paper from Wodzinski in 2021. As the ecosystem approaches its climax community, these old growth trees will have had the opportunity and time to reestablish their dominance, and the ecosystem will likely return to a similar state pre-hurricane.
This experiment was conducted to measure evenness amongst tree species in Point Pleasant Park following Hurricane Juan in 2003. Density and species identity were used to calculate evenness on an annual basis. The data, along with a regression analysis, is displayed in the figure above. Evenness becomes slightly lower as time progresses after the hurricane, and the R-square value of 0.028 indicates a slight correlation between years past and evenness. However, a p-value of 0.15 at 1 and 72 degrees of freedom indicates that we cannot reject the null hypothesis at a significance level of 0.05. This means that there is not a statistically significant correlation between tree species evenness in Point Pleasant Park and the progression of time. As displayed in the graph, evenness gradually declines throughout the succession process. This can be attributed to the increase in numbers of both dominant species, red spruce and red maple. As these two tree species occupy a greater portion of the forest in Point Pleasant Park, evenness becomes reduced. As the forest moves towards its climax community, it is likely that evenness will begin to plateau as the forest reaches maturity. Succession theory predicts that evenness declines, then increases 5 years after the disaster, then decreases once more before remaining constant. The first half of that trend is visible through the individual points above, as we can see J increase around 2010.
The disturbances caused by Hurricane Juan in 2003 did not drastically affect the soil structure and its nutrient composition in the park. The Point Pleasant Recovery Plan outlines the effects of and ways to improve soil quality following the hurricane. Many of the fallen plants and tree species were embedded into the soils, improving the soil structure and root strength of trees. The uprooting of trees mixed the upper and lower soils, exposing the mineral-rich soil layers and seed banks to the top. The removal of woody debris initially after the hurricane affected the over-rising of soil, as the decomposed organic matter was not incorporated into the soil. This affects soil fertility and composition, which can be improved by minimizing operation disturbances and leaving all fine and coarse wood debris on site. The B horizon of the soil was found to contain more organic matter due to the constant disturbances in the park. Burley in 2008 found that biomass removal had no significant differences in nitrogen and phosphorus content in Point Pleasant soil versus the reference sites, as lots of fine leaves and plant litter had been left to be incorporated into the soil.
Collecting annual data on the succession of the Point Pleasant Park forest following Hurricane Juan in 2003 gave insight into the park management techniques that best support regeneration. In 2010, in a study on the park's succession, James Steenberg and Peter Dwinker state how red spruce is a shade-tolerant climax species in native Acadian forests, which allows it to regenerate faster. The report discusses how the sites in the regenerated forest that were densely populated with red spruce could be used as donor sites for those that were more sparsely populated. Since individual growth is a function of density, this would also improve the health of the densely populated communities. This study also found that it was beneficial to plant native species in more barren areas to prevent invasion by exotic species that could pose a competitive threat. Noting ecological patterns like red spruce dominance, maximum capacity, and invasive species, and using strategies like transplanting can be beneficial as they can be applied to helping a forest return to its natural state after an ecological disaster.
If another hurricane were to strike Point Pleasant Park today, the resulting devastation would likely mirror the events of 2003. Trees would be uprooted and scattered across the landscape, while smaller plant species would meet the same fate or be crushed by falling debris. Like what happened after Juan shown in results 1 and 3, species diversity would plummet and species evenness would increase since only climate-resilient species would remain in the park. Overall, if you took a walk through Point Pleasant in 2003 after Hurricane Juan, it would look the exact same as if a different hurricane hit today. However, while the park might look the same after another hurricane, the species composition most certainly would not. Point Pleasant Park is currently in a juvenile stage per se compared to its health pre-Juan, far from its climax community as an old-growth evergreen forest. If we look at the dominant species in Point Pleasant, red spruce and red maple, both are incredibly slow-growing trees. As mentioned in results 2, red spruce take 200 years to reach maturity, whilst red maple takes 70 to 80. Hence, none of Point Pleasant's dominant trees have had time to reach sexual maturity yet, thus cannot reproduce since the mature trees were killed during Juan as seen in the figures in results 2. Ultimately, another hurricane looks bleak for Point Pleasant Park. Perhaps some of the dominant trees would survive and we would see a succession identical to 2003, or perhaps the forest would be leveled and Point Pleasant would succeed into a new forest composition.
The data collected in the 20 years following the effects of Hurricane Juan on Point Pleasant Park demonstrate the regeneration patterns of the forest. Based on the provided data, it appears that the Point Pleasant Park forest is in the late stages of succession. The climax community has not fully been reached, however, there is an increasing abundance of shade-tolerant tree species, including red spruce. This can be partially accredited to the many regeneration efforts that have taken place over the past 2 decades. Succession can be impeded upon by an urban environment. Anthropogenic activity can hold a negative impact on seed banks, making it difficult for trees and vegetation to grow. Additionally, urban areas pose stressors, such as abundant squirrel populations, that also infringe on trees' ability to grow. The Mi'kmaq concept of niticulink highlights the values of interconnectedness, reciprocity, and responsibility. Our relationship to the land is a large component of this, and Mi'kmaq culture greatly values giving back to the land and fostering a reciprocal and respectful relationship with nature. This applies to the forest in Point Pleasant Park, as the forest is a valuable resource to the people of Halifax. It holds instrumental, recreational, and spiritual value. After the devastation caused by the hurricane, it was important to aid the forest in regenerating itself by planting trees and cultivating healthy soils. With further integration of Mi'kmaq values in environmental management, conservation and regeneration efforts can be strengthened, which will in turn reinforce our ties to the land.
We acknowledge that Point Pleasant Park is in Mi'kma'ki, the ancestral and unceded territory of the Mi'kmaq people, and pay respect to the Indigenous knowledge used to help restore and care for the park. Thank you to the Dalhousie Fall Term Ecology students for continuously collecting the data for tree densities and diameter breast height. Another thanks to Dr. Allison Schmidt for preparing the data and regression analyses that were used in our presentation.